Verifying trig identities final example. We've been verifying these identities all throughout the chapter. Of course, every time we meet a new kind of advanced identity, we can use those to further help us to verify other identities. Here's an example. We'll use our standard technique here. We'll see if we can make these two sides match. So there's a lot going on here. You could look at this and think about double angle identities, but wow, that seems like it would be complicated. What you're supposed to notice here is, well, I do have two cosine functions being subtracted. Here I have two sine functions being subtracted. The angles are different in each case. Well, that makes me think of the sum to product identities, where I have a sum or difference and I can change to a product. And I'm thinking the advantage of changing to products is when everything is multiplied, perhaps some things will cancel out, will divide out. So let's grab the identities we need. Okay, so here are those sum to product identities. What am I going to need? On the top there, I have a cosine minus cosine. That's this one. And on the bottom, I have sine minus sine, which is this one up here. So, it's just a matter of directly substituting in. We have the left side. We're going to replace it with the right side. I'll start with the top. Cosine A minus cosine B, negative 2 sine, and then I make this fraction. It's the two angles added, so 4x plus 2x divided by 2. And then times, and then this fraction has those two angles subtracted and divided by 2. The denominator, now I'll use this top identity here. So sine A minus sine B is what I have. That's equal to 2 sine, let's see, here I do A minus B, that would be 2x minus 4x. Right, here's my A and here's my B, divided by 2. And then the other one up there is a cosine, and that is A plus B, so 2x plus 4x over 2. And then I have a bunch of simplifying to do. Let's see, up top there, 4x plus 2x is 6x, divided by 2 would be 3x. And for the other one, 4x minus 2x is 2x, divided by 2 is just x. On the bottom, I've got that 2x take away 4x, negative 2x divided by 2 is negative x. And I think I've got another 3x for the other one, right? 6x divided by 2. Okay, now so far, maybe we're wondering, is this really helping? Sometimes we try things and it doesn't help. Here's what I notice. I've got that sine of negative x, but I can use the negative angle identity for sine in order to rewrite that. Let's do that. I'm not going to touch the top at the moment. But on the bottom, sine of negative x is equal to negative sine x. Right? That's one of our identities. We call it the negative angle identity. Sine of negative x would be negative sine x. So I'm going to get a negative out in the front there, and then sine of positive x. Well, that's the breakthrough that we needed to happen, because now I have a lot of factors that match. The negatives, of course, plus out. The 2's can divide out. The sine x's can divide out. I'll continue over here. I'm left now with just sine 3x over cosine 3x. And using the quotient identity, that is equal to tangent of 3x. And that's what we needed. Our two sides match, and so we have verified the identity. Thanks for watching.